Assalamualaikum and a very good day to Doctor. We are from Group 5, which is Muhammad Nazif bin Nasir, me, Siti Nufatin binti Kamisan, Tan Gining, Tan Sushan, and Wan Azwa Aisyah bin Wan Azahar will present our assignment 2, which is the sample preparation, instrumental analysis, calibration and analysis, and reporting of results. So we decided to choose red wine as our sample, and red wine is an alcoholic beverage made from fermented dark colored grapes. The grape skin, the seed, and sometimes the stem are included during the fermentation process, imparting the characteristic red hue to the wine. The red wines can vary widely in flavor, ranging from light to fruity to bold and tannic, and they often develop complex aromas and flavor as they age. The red wine also stands out as a highly intricate and diverse liquid compared to other beverages. Its quality is notable influenced by the presence of multitude of compounds, including water, ethanol, mineral, inorganic and organic substances, carbohydrate, and also polyphenol. Okay, so here is the list of analyte that we found in the red one. And the analyte chosen to be analyzed is anthocyanin, which is anthocyanin is a phenolic compound and it contribute to the red color, the astringency, the flavor, and health benefit. Okay, so here is the sample preparation to prepare anthocyanin from the sample, which is the red one. So the first one, homogenization and conditioning, where we do the mixing, the decanting, and the filtration. And the second one is the extraction of anthocyanin. As we know, anthocyanin is a phenolic compound. So the technique that's suitable for it mostly is the solid phase extraction or liquid-liquid extraction. So the step is to mix the red wine with an acidified organic solvent and then use a solid phase extraction SPE method or other suitable extraction technique to isolate anthocyanin from the sample. The SPE cartridges with C18 solvent are commonly used for anthocyanin extraction. Okay, the third step is elution, where we elute anthocyanin from the SPE cartridges using a suitable solvent such as a mixture of acidic methanol or ethanol. And the fourth step is concentration, where we concentrate the elute using a nitrogen evaporator or a rotary evaporator to remove the solvent and to obtain a more concentrated anthocyanin extract. And the last step is filtration, where we filter the concentrated extract through a zero point 0.2 μm filter to remove any particulate matter.
Okay, I will continue the presentation with the instrumental analysis technique. The instrument used to detect our analyte, which is anthocyanin, is high-performance liquid chromatography (HPLC). HPLC is a widely used analytical technique in chemistry and biochemistry for the separation, identification, and quantification of chemical compounds. And here are the basic principles of HPLC. HPLC is based on the principle of liquid chromatography, where a liquid mobile phase carry out a sample to a stationary phase, and the separation is achieved based on the differential interaction of the sample component with the stationary phase. And these are the setup and the instrumentation of HPLC, which is consist of HPLC pump, injector, HPLC column, detector, and the data computer for the analysis. Next is the procedure of handling HPLC. First, make sure all the equipment and buffer were set up, and then open all the valve of the system for about 5 minutes, and after 5 minutes, add the sample into the auto sample tray, and then run the system at the normal flow rate with the buffer to equilibrate the column for 10 minutes, and make sure that the pressure is stable, and then set up the sequence method for the analysis. And the last one, run the standard before the actual sample as a part of the same sequence.
Next is advantages of HPLC. The first one is high sensitivity, use of various detector, which is UV conductivity detector, fluorescence detector, and also electrochemical detector. It can detect from ppm to ppt. The second one is quick and efficient. Compared to other instrument, HPLC is quick and efficient analysis. The usage of pump to fourth mobile phase through a solid absorbent material. It has high resolution and also accuracy. Number 3 is wide analytical application, used to analyze the particle, organic and inorganic material. normally used in food industry to detect the food components and also toxins. Next, proceed with the limitation. The first one is column selectivity. The choice of HPLC column may impact separation efficiency and also required optimization. Number two is sample preparation. Incomplete or improper preparation can lead to extraction issues or metric interference. Number three is metric effects. Once complete metrics can cause co-illusion, affecting detection and also quantification. Number four is stability of anthocyanins. Environmental factors can impact anthocyanins stability during analysis. Number five is quantification and calibration. Lack of standard of all anthocyanins may affect accurate quantification. Proceed with the limitation. Number six is sensitivity. Limited sensitivity may pose challenges in detecting trace amounts of anthocyanins. Number seven is co-illusion of isomers. Separation difficulties may arise with structural isomers. Number eight is mobile phase selection. Finding a universal mobile phase for all anthocyanins can be challenging. The last one is time and cost. HPLC analysis can be time-consuming and also costly, especially with rigorous optimization.
I'm Gining, and now I'm going to explain the protocol for the analysis of our sample. There are three protocols to be followed for the analysis of our analyte, and the first step is calibration. Transfer known quantities of the anthocyanins present in red wine into volumetric flux to create a series of standard solutions. To ensure precise transfer, pipettes are utilized, and then solvent is added. Then, inject these standard solutions into the HPLC system to create a calibration curve that correlates peak area with concentration. It is recommended to filter both calibration sample and standard solution before their injection into the HPLC to remove any fine particles that might obstruct the instrument. The next protocol is sample analysis. If required, dilute the red wine sample to fit within the linear range of the calibration curve. Then, proceed to inject the filtered and appropriately diluted red wine sample into the HPLC system, ensuring uniformity in the injection volume for all samples. Lastly, the final protocol is quantification. There are three parts in quantification. The first part is peak integration. Following the completion of the HPLC analysis, utilize the software linked to the HPLC to conduct peak integration. This process entails recognizing and measuring the area under each peak in a chromatogram that corresponds to specific anthocyanins. Next is the calibration curve. Refer to the calibration curve previously created utilizing standard solutions of non-concentration. The peak areas of these standards were employed to establish a linear correlation between the peak area and concentration. Lastly is the concentration calculation. Utilize the calibration curve on the peak regions that were identified from the sample of red wine. The concentration of every anthocyanin in the sample will be determined by the software using the curve equation.
Next, the standard method that complies with our analyte during analysis is OIV-MA-AS315-11. It includes details such as sample preparation, sample analysis, instrument parameters, and expression of results. The analytical method focuses on assessing the proportional composition of anthocyanins in red wine. In this standard method, separation is conducted using high-performance liquid chromatography, which is HPLC, equipped with a reverse phase column and ultraviolet visible spectroscopy detection. Lastly, we had concluded some essential elements in reporting of results. First is results presentation. List the concentrations of each identified anthocyanin and present the results in suitable units such as milligrams per liter or parts per million. Secondly, quality control. Integrate details about quality control procedures encompassing the use of blank samples, duplicates, and spike samples. Provide an explanation of how any problems or deviations encountered during the analysis were addressed. Next, uncertainty and precision. It provides details regarding the precision of the analysis such as standard deviations or relative standard deviations. If accessible, communicate the measurement uncertainty, taking into account factors such as instrument, variability, and sample preparation. Furthermore, comparison with standards. It is vital to compare the results with the anthocyanin levels in red wine that correspond to the reference values or allowable limits. Last one is discussion of results. Discuss any trends or reference seen in the anthocyanin profile based on generated chromatogram. It's also important to take into consideration how the outcomes may affect the red wine's quality or features. So that's all from Group 5. Thanks for watching.